All right, if you're getting ready for the AP Computer Science A exam, you know that Boolean logic can get a little tricky, especially when you're under pressure. Well, in the next few minutes, we're going to break down one crucial law that will make simplifying complex logic a breeze and help you sidestep the most common traps on the test.
Okay, so let's just dive right in. We're going to start with a challenge you might actually see on your exam, something that looks way scarier than it really is.
Okay, picture it. You're in the middle of the exam, the clock is ticking away, and you see this expression pop up. I mean, it looks confusing, right? Your first thought might be to just panic a little, but what if I told you there's a super simple trick to unravel this thing? By the end of this explainer, you'll find it easy. I promise.
So, to solve that puzzle, we first need to get our tools in order. We've got to start with the absolute fundamentals, the basic building blocks.
Everything in Boolean logic, I mean everything, boils down to this one simple type. It can only be true or false. That's it. It's kind of like a light switch, It's either on or it's off. There's no dimmer switch, no in between. And that simplicity is actually what makes it so incredibly powerful.
Okay, so how do we work with these true and false values? Well, we've got three main tools, our logical operators. First up is not, the exclamation mark. It's super simple. It just flips a value. True becomes false, false becomes true. Easy. Then we have and, written with two ampersands. You can think of and as the strict one. It needs both sides to be true for the whole thing to be true. And finally there's or, the two vertical bars. Or is way more chill. As long as just one side is true, the whole expression is true. Now this is super important. Just like you have PEMDAS in math class, Java evaluates these operators in a specific order. It always does not first. Then it handles all the ands, and finally, last on the list, is or. You gotta remember this order, because getting it wrong will totally change the answer. It's one of those details that's absolutely crucial.
Now you could try to memorize these truth tables, but honestly, who wants to do that? There's a much easier way. Just remember this. For and, it's only true when both inputs are true. If even one is false, the whole thing is false. And for or, it's the exact opposite. It's only false when both inputs are false. If you have even one true in there, the whole thing becomes true. Simple, right?
Okay, basics are down. Now, let's get to the good stuff. We're about to reveal the pro move, the secret weapon for simplifying those nasty negated expressions.
And that secret weapon is called De Morgan's Law. Seriously, don't think of this as some boring rule you have to memorize. It's more like a powerful shortcut, a cheat code for your exam. It's your ticket to taking something that's really confusing and making it simple and clear.
And check this out. The pattern is so simple and elegant. When you distribute that not across the parentheses, you apply it to both A and B. But here's the magic trick. The operator in the middle always flips. The and turns into an or, and the or turns into an and. That's it. That's the core idea. So if there's one phrase you walk away with today, let it be this one. Break the line, flip the sign. That's the key. You break that not line over the whole expression, and you flip the sign in the middle. And becomes or becomes and. Got it? All right, now that we have our secret weapon, let's go back and solve that puzzle from the beginning. You're going to see how easy this is. Okay, let's break this down systematically. Step 1, we identify what we're looking at. This is a classic not A and B situation. Step 2, we apply our rule. Break the line, flip the sign. So we distribute the not to both parts. The score greater than equal to 70 gets a not, and the attempts less than 3 gets a not. And that and in the middle, it flips to an or. Step 3, and this is the final piece, we just simplify those individual negated parts. And boom, there it is, the simplified expression. Score less than 70, or attempts greater than or equal to 3. Now the crucial point here is that this new version is logically identical to the original. It does the exact same thing. But just look at it. It's so much easier for a human to read and understand. Your brain doesn't have to do that mental gymnastics of processing a giant knot wrapped around the whole thing. This is a huge deal. Here's how this looks in some actual code. You see this kind of if statement all the time. And yeah, it works, but it's clunky. It makes you stop and think, wait, not age is greater than or equal to 18 or has permission? What does that even mean? It's just not intuitive. But now watch this. We apply De Morgan's Law. We break the line, flip the sign, and we get this. If age is less than 18 and they do not have permission. See?
So much cleaner. It's direct, it's what you actually mean, and honestly, code that's easier to read is code that's less likely to have bugs.
Okay, so knowing the rules is one thing, but to really maximize your score on the exam, you need to know the common mistakes people make. Let's look at the traps so you can dodge them.
These are the 4 most common errors that cost students points, for sure. Forgetting to flip the operator, that's a basic one. But the one about dropping the boundary on inequalities, that's a big one. And misunderstanding short-circuiting, that can be tricky. So let's make sure you've got these locked down.
Okay, listen up, because this is probably the single biggest trap on the exam. When you negate x greater than 5, the opposite is not x less than 5. That's wrong. The opposite of greater than is less than or equal to. You have to include that boundary. Don't drop the equal sign. It's a super common mistake, so don't let it be yours.
All right, let's talk about something called short-circuiting. Basically, Java is efficient. You could even say it's kind of lazy, in a good way. If it's looking at an AND expression and the very first part is false, doesn't need to check the rest. Nope, it already knows the whole thing is false. So it just stops right there. It short circuits. Same thing with OR. If the first part is true, it knows the whole expression is going to be true, so it stops and moves on. This isn't just about being fast. It's a critical feature that helps prevent your code from crashing.
So let's wrap this up. What are the key takeaways you need to have burned into your brain for the exam? Number 1, operator precedence. It's always not, then and, then or. Number 2, De Morgan's law. Just remember, break the line, flip the sign. And number 3, and this is a big one, negating inequalities flips the sign and includes the boundary. Greater than becomes less than or equal to. Got it?
Okay, to finish up, here's a real sample question. Let's see if we can crack it together. We're looking for an expression that's equivalent to this one. Now, just focus on that first part, not x or not y. Does that look familiar? It should. It's what you get after you've applied De Morgan's law. So let's try working backward. Let's unbreak the line and flip the sign back. So not x or not y becomes not x and y. See that? And then we just tack on the or z at the end. And there you have it. The answer is B. This is a classic exam trick, making you use De Morgan's law in reverse.